Hi, welcome to my video on half-angle formula for tan number 2. Solve for theta 0 less than or equal to theta less than 2 pi. So we're going to want the answer in radians. And we're going to solve it two different ways. One of the first ways that I would think to solve this would be to square both sides. So if I take 1 plus cos theta over 2 and square the left side, and I square the right side, then when I square a square root, I just get what's underneath the root, 1 plus cos theta over 2, and 1/2 squared is 1 times 1 is 1, and 2 times 2 is 4. So we cross multiply, we get 4 times 1 plus cos theta equals 2 times 1. So that's 4 plus 4 cos theta equals 2. And we're going to solve it for cos theta. So we move the 4 to the right side, make it a minus. 4 cos theta equals negative 2. Divide by 4. And I get cos theta equals, and that cancels out, and so that's a negative 1 over 2. So cos theta is a negative 1 over 2. And so the way I do it, I do the cos of the reference angle, and I make the negative a half positive. So cos is a half, and when I think of that, I think of the special right triangle, which I have 30 and a 60 and a 90, 1 root 3, 2. So the cos, so the reference angle, is cos of 60. So the answer is 60. Cos of 60 is 1 over 2. So that's a 60-degree reference angle. Now I think of, that's a negative, so I'm going to add sugar to coffee. So cos is the x, and cos is negative. Cos is positive in 1 and 4, so it's negative in 2 and 3. So we'll draw it in quadrant 3, and we'll, draw it in quadrant 2 with a reference angle of 60, which is right here. So this rotation is 180 minus 60, which is 120. And in quadrant 3, the reference angle is 60, and the rotation is right around, so it's 180 plus 60. So that's 240 degrees. And we want that answer in radians. So 60 is a pi over 3, so there's 2 pi over 3s there, so there's 2 60s, and there's 4 60s. So it's 4 pi over 3. Or we could go 120 times pi over 180. And the zeros cancel. 6 into that goes 2. 6 into that goes 3. That's another way to convert. But I remember that 60 is pi, 180 divided by 3. And there's 2 of them here and 4 of them here. Oop, that's a 4 pi over. I almost made a mistake there. So that's one way. So what's another way to do it? Well, I look at here and I see this is a half angle formula. So this is a half angle formula, and that's a plus, so that's the cos. So that's the cos of theta over 2 equals 1/2. Again, that's a half angle formula for cos of theta over 2. And so now we have the cos, again the same as before, the reference angle is positive anyway. So the reference angle for a half, we did it right here. It's 60, but this time we're dealing with 60. So let's see, we're going to add sugar to coffee. And cos is positive in 1 and 3. Sorry, cos is positive in 1 and 4. What did I say 3 for? There's 2 and 3 there. Cos is positive in 1 and 4, so we'll draw it in quadrant 1. I'm going to draw it in quadrant 4. So the reference angle is 60. So in this quadrant, we have automatically it's a 60. And in quadrant 4, the reference angle is between the terminal arm and the x-axis. So do your rotation right around. So that's 360 minus 60, which is 300. So now what we have theta over 2. So that means theta over 2 equals 60, and theta over 2 equals 300. So we cross multiply. We get theta equals 2 times 60 is 120, and cross multiply over 1. Theta is 2 times 300, which is 600. So 120 is okay, which is right here. But 600, if we rotate 600, so we can do a couple of ways. We take 600 is too large because we got that between 0 and 360. So 600 take off 360. So 600 take off 360 is the 240, which is what we have right here. So we got 120 and 240, and 120 is 2 pi over 3, and 240 is 4 pi over 3. So just another way to do it. So there's two ways to solve this equation. Okay, let's continue. Now, prove that the tan of theta over 2 equals sine theta 1 plus cos theta. Well, we have a left side, which is the tan, and we have a right side. This is tan of theta over 2, and the right side is the sine of theta 1 plus cos theta. Now another trick to this, what we're going to do is I'm going to work this side, but I'm going to replace theta with theta divided by 2. So sine of theta over 2 is 1 plus cos of theta over 2. So when I do that, I'm going to replace it with this, but not replace it. So if I want theta, I got to go 2 times theta over 2. And this is 2 times theta over 2. 2 times theta over 2 is the same as theta. And 2 times theta over 2 is the same as theta. Okay, so this is the half angle formula, the double angle formula for sine. Half angle is here, but it's a double angle because it's sine of 2 times this angle. So that's the double angle for sine, so that's 2 sine of theta over 2 cos theta over 2. And this is the cos of 2 times theta over 2. So another name for cos, that's the double angle formula for cos. So let's go with 2 cos squared theta over 2 minus 1. And again, this is double angle for sine here, which is right here. This is the double angle for cos, which is here. Notice the 1 and negative 1 cancels out. So I get, so this is, the 2's cancel out. I subtract those, and I get 2 sine theta over 2 cos theta over 2. And this is left, so I cancel the 2's. And this is a cos squared, and this is a cos. So this cancels out, and the 2 cancels. So I get the sine of theta over 2 and the cos of theta, make that a theta over 2. And the sine of theta over 2, cos theta over 2, is the tan of theta over 2. And we have it proved. But notice we replaced theta with 2 times theta over 2. So that gives us a double angle formula for sine and cos. And I always write the statement since the left side equals the right side, it is an identity. Now, let's find the exact value for the tan of 195 using the formula above. So the formula above is this one. So we have the tan of theta over 2 is the sine theta divided by 1 plus cos theta. And right here, so this is the tan of 195 is, if you double 195, so that's 2 times 195 over 2. And so that means that we have, that's the tan of 390 degrees over 2. So that means theta is over 2, so that means theta is 390, so that's the sine of 390 degrees, 1 plus the cos of 390 degrees. And 390 degrees, well, let's look at 390. 390 is more than one rotation, so we take off 360, so that's 30. So the sine of 390, if you think about a circle, 390 is right around here, that's 360, and right here, so 390 degree rotation is from here right to here. This is a 30 degree angle, so that's at the same equivalent. So we change 390 to 30. Change 390 to 30. And again, we got a 30 degree angle. We got a 30, 60, 90, 1, root 3, 2. And the sine of 30 is the opposite of hypotenuse. So that's 1/2. And 1 plus the cos of 30 is the adjacent over hypotenuse, which is root 3 over 2. And we have, we got complex fraction, fractions on the top and the bottom. So the common denominator is 2, so I will multiply the 1/2 by 2 to get a 1. And I multiply the denominator by 2, so 1 times 2 is 2. And 2 times root 3 over 2 is root 3. And we have to rationalize, so we multiply it by 2 minus root 3 over 2 minus root 3. And that gives us 2 minus root 3 in the numerator. And when I multiply, these are conjugates of each other, radical conjugates. So I just got to multiply the first two, which is 4, and multiply the last two, which is -3. I don't have to do the outside-inside on conjugates. If I did, I get -2 root 3, +2 root 3 to cancel it. So that's 2 minus root 3 over 1, which is 2 minus root 3, which is the exact value for the tan of 195. I didn't want a decimal. I could use my calculator very quickly and get a decimal for that, but I didn't. I wanted an exact value. And besides that, there's another name for, I use this formula right here, but there's another name for tan. We could have also used tan of theta over 2 is plus minus square root of 1 minus cos theta over 1 plus cos theta. And I could have used this one to get the tan of 190, this formula, and I would have come up with the same answer. So this is a quicker, this formula here is faster to do if you remember it, but I always remember this one. I would have gone this way because I keep this in my head, and the more formulas you got to learn, probably sometimes the more confusing it gets. So again, I could have taken this tan of 195 and worked it out with this one, doing tan of 390 over 2 and plugged it in here I would have plugged the 390 in here and here, and it would have worked out. And 390 is positive, so I would have said it would have been positive. Okay, so that's another video done. And again, if you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope this video helped you. Bye-bye.